So, good evening, class. In the series of fundamental of physics, today we will be going to understand the basic concepts of measurements, units, and dimensions. And it is because this topic it is the basic concept of the physics, so it needs more understanding and more, you can say, depth of gravity it needs. So, first and foremost, we will understand the basic concept of physics. So, as the term here indicated, it is physics. What is the term physics? What is meant by the term physics? As we are seeing in our nearby world and the environment, there are a lot of conversions are occurring. Somewhere tsunami is coming, somewhere earthquake is coming, somewhere cyclonic effect is also there. The all the type of conversion which are occurring in this the conversion may be in the form of energy transfer, or it may be in the form of, you can say, different type of transfer is occurring in the season. The seasonal change is there, the rotation of earth is there, the falling of apple under the influence of gravity. So these all type of conversion are occurring because of certain rules and regulations. There are certain principle which is governing these certain rules and regulation. So, what is the physics? Physics, it is the studies of laws of nature. Whatever the laws of nature is there, coherent to which this type of conversion is occurring in our nearby environment. As a result, so that is known as the physics. And as we had already studied in our earlier classes and our lower classes also, the different type of energy conversion. Suppose the kinetic energy is converted to potential energy. The potential energy is converted furthermore to other forms of energy. We had already studied the conversion of energy in which either energy is neither created nor destroyed. It is changing its form from one form of energy to another form of energy. So, what is this type of conversion of energy? What is this seasonal variation, the periodic variation? What is the different type of, you can say, the occurrence which is occurring as a result of the, because these all things are occurring because of certain rules and regulation. There are certain principles of laws of nature. There are certain principles and laws of nature. Because of that only this type of change we are observing in our nature. And what is physics? Physics, it is the study of laws of nature. It is the branch of, you can say, it is a branch of science which deals with the laws of nature. Why this type of changes had happened? Suppose you are holding an iron rod in your hand and you are placing a candle in the, you can say, in at the one end the candle is there. After some time you will feel the heat in your in the iron rod. So why such type of thing is occurring? So physics gives the answer for all such things. So we can say, we can conclude here that physics is the law of study. Physics is the study of laws of nature and the basic principles. And these, the physics, it is the one of the most important subject in the branch of science. So it is the basic concept that I had given to you, that physics is the study of laws of nature. So we will just go through gradually and slowly. Physics, it is the study of laws of nature. It is the study of laws of nature. As there are various laws of nature are there, suppose we are taking the example of gravitation effect, the gravitational force between the two masses placed at a certain distance. The distance between the two masses, suppose r. So we can write the expression F is directly proportional to m1 m2 by r square. We can remove the constant of proportionality. We can remove that proportionality constant with the help of, you can say, k. F is equal to k, or F is equal to capital G m1 m2 by r square, where capital G denotes the universal constant, the gravitational universal constant. So how this formula had been derived? This formula had been derived because the scientists had observed, they had applied the basic principles, basic laws of nature, and after certain heat and trials, after certain experiments and observations, they had given one formula. That is the formula. It is F is equal to G, capital G m1 m2 by r square. Suppose it is the study. It is the force is equal to capital G m1 m2 by r square, where capital G is the universal gravitational constant, and m1 m2 are the respective masses of the body, and and r is the distance between the two masses. They are placed at a certain distance, and this r is having the inverse relationship with respect to the force. So how this formula had derived, I had already given you the basic contents regarding that. They had many scientists are there, they are working on the same, they had worked there, they had worked, you can say, day and night, and they had came to a conclusion that force is equal to capital G m1 m2 by r square. Now we will see the relationship between the physics and the mathematics. The relationship between the physics and the mathematics. Relationship between physics and mathematics. See, the physics is the study of laws of nature, as we had already studied here. Now comes the mathematics. Mathematics, it is supposed to be the language of physics. We are knowing the basic concept that how how the apple is falling under the influence of gravity. But to prove it, but to deduce the equations, but to prove it, but to establish a certain relationship between the known and the unknown quantity, or between the two quantities, we are taking the help of mathematics. Mathematics, it is also the broad concept, it is having a broad, you can say, applications in the physics. It is supposed to be the language of physics. In physics we are studying the laws of nature, but to establish the relationship, but to prove that how it is coming, how it had been derived, then we are taking the help of maths. So math is the language of physics. Now today we will be going to learn the topic name, that is measurement. So we will be starting from the base and we will go to the upper level. So we will be starting from the base, that is measurement. So measurement, as the term suggests, the measurement, it is a process. It is a process of comparing an unknown quantity with a known fixed quantity. Measurement means to compare an unknown quantity with a known fixed quantity. So it is a process of comparing an unknown quantity with a known fixed quantity. There will be two entities under the measurement. One is the unknown quantity, and secondly, known quantity. So measurement is the process of comparison. It is a process of comparing the unknown quantity with a known fixed quantity. Suppose we are taking the example of a physical balance, in which on the right hand side we are keeping the known quantities. There are certain iron weights are placed on the right hand side, which we are knowing what is the magnitude of the same, that is the known quantity. And on the left side of the pan we are keeping the object whose weight we want to calculate, whose weight we want to calculate. So we will we will add or subtract the multiples of the known weight, so that till both the pans become equal. So that is the process of measuring. We are adding or subtracting the known weights, so that both the pans become equal. That is the process of measurement. So we are comparing how many times the known quantity is contained in the unknown quantity. How many times the known quantity is contained in the unknown quantity. So that is the process, that is the measurement. Measurement means to compare an unknown quantity with a known fixed quantity. So we had taken the help of the physical balance. We had taken the example of the physical balance, in which we had seen that in the right hand pan we have to add or subtract the known unit, so that particular entity is equal to the left hand side, left pan. And we will continue this measurement until and unless both the pans will be at equal height. So that is both the pans will be in equilibrium. So that is the process of measurement. So in this case I had given you the example of a physical balance. Physical balance. And this process, the process of measurement, the similar process of measurement It is applicable for other applications also. So we had covered the topic of measurement, and I had given you the definitions for the same. Measurement means to compare an unknown quantity with a known fixed quantity. So we will be moving further regarding this, taking the concept of the measurement. The first is the known quantity. Now we will be switching over to the known quantity. The known quantity, it is the unit. It is known as the unit. The known quantity, it is known as the unit, and that is standard, that is acceptable in universally, and those magnitude, those unit, it has certain, you can say, the notation is there, and it is standard. Its value is not changing. Its value is firm, and it is fixed, and it is universally accepted by the international system of units. So the known quantity, it is known as the unit. So in this case, we can define unit as a known standard quantity whose whose magnitude is not changing with respect to the time, position, and other factors, and through which we can compare the unknown quantity. The known quantity can be anything as per the measurement criteria, as per the situation we are considering the unknown quantity. So we have defined the unit. Unit is a fixed standard quantity. Unit is a fixed, it is a fixed standard quantity, whose value does not changes with respect to time, place, etc. Used to compare unknown quantity. Used to compare unknown quantity. So these are the 5 points related to the unit. The first and foremost, it is a fixed quantity. It is a fixed quantity. Secondly, it is a standard quantity. Standard means it is not changing with respect to the time, place, etc. It is used to compare unknown quantity. So I had also already given you the example of a physical balance in which we had seen there are the two types of pans we are using. There are two types of pan, the left pan and the right pan. In the left pan we are keeping the unknown quantity, and the right pan we are keeping the known fixed standard quantity, that is unit. So we will be keep on adding or subtracting the units, the iron loads, till both the pans become equal. That is the full process of measurement, and that defines the unit. Now we will be switching over to the classification of units. So the classification of unit itself is a broad concept, and its classification, it is broadly classified into two types. The unit is broadly classified into two types. We will just go through the classification of unit. It will be easy for you to understand the underlying concept behind the same. Please focus on the board. We will be just switching over to the classification of units. The classification of units. It is fundamental unit and derived unit. So when we are dealing with the classification of units, the units are broadly classified into two types. One is the fundamental unit and the other is the derived unit. The fundamental units are the basic units, which we had already discussed. These are the basic units which are standard in nature, whose value does not changes with respect to the time, position, any other factors, and these are the known fixed quantity. And you can say we are taking the types of fundamental units. There are different types of fundamental units are here. Suppose mass is there, length, time, temperature, electric current, amount of substance, luminous intensity, radian, and solid angle steradian. These are the supplementary units. So Whenever now switching over to the types of fundamental units, there are basically seven type of fundamental units which are universally accepted. They are standard in nature. Their values does not changes with respect to the time, position, and other factors. So coming to the types of fundamental units, there are basically seven type of fundamental units are there. The first is the mass, second is length, time, temperature, electric current, amount of substance, luminous intensity, radian and steradian. Unit of mass is kg, unit of length is meter, the unit of mass is kg, unit of length is meter, unit of time is second, unit of temperature is Kelvin, unit of electric current is ampere, amount of substance is mole, luminous intensity candela. And there are, apart from these seven fundamental units, we are having the two supplementary units. They are radian and steradian, solid angle steradian, and the radian is also there. So these are the seven fundamental units are there. Now switching over to the derived units. The derived units, as the name suggests, as the name defines itself, that derived units are basically those units which are derived from these units only, which are derived as a result of mathematical operations. They are basically dependent on the fundamental units. So these are the derived. Suppose we are taking the example of force. Force is equal to mass into acceleration. Force is equal to mass into acceleration. As per the Newton's second law of motion, the rate of change of linear momentum is directly proportional to the force applied, and this effect will be in the direction of force applied only. In which direction we are applying the force, in that direction only there will be the rate of change of momentum, that is m. Force is directly proportional to m v minus u by t. It is force is equal to ma. Now we had got this force, this quantity force. It is a result of the product of mass and acceleration. Mass is m, it is mass m, and acceleration lt minus 2. That is change in velocity or velocity by time. So we had got this derived unit force as a result of multiplication of two quantities, that is one of the fundamental unit mass, and acceleration, it is the result of the operations between the two quantities, that is length and time, that is also two fundamental quantities. So concluding this, taking the observation of this, we can conclude that the derived units are the result of the operations between the quantities, and it can be said that derived units are dependent fully on the fundamental units, and they are the outcome of the operation of the fundamental units only. So this is the basic which we had defined, which we had covered between the fundamental and derived unit. Now coming to the next topic, we will be covering one of the most important topic in the measurement, that is dimensions. And we will be reducing some of the relationship which will be beneficial for us. So please focus on the board. We will be covering the most important topic, that is dimensions. Dimensions. So dimensions. Dimensions, it is one of the most important topic in the physics, dimension, and it is covering under the measurement. The measurement is the main topic, and it can be categorized as the subtopic under the measurement, that is dimensions. Dimension is that, suppose we are taking any equation. Suppose we had taken equation force equal to mass into acceleration. The force is equal to mass into acceleration. The force is equal to mass into acceleration. When force is equal to mass, we can write m to the power 1 into lt minus 2. L to the power 1 and t to the power minus 2. So we are seeing in this equation that m is raised to the power 1, L is raised to the power 1, and t is raised to the power minus 2. So whatever exponents it is coming in this particular equation of the units, of the fundamental units, that is known as the dimension. M is raised to the power of 1, L is raised to the power 1, and t is raised to the power of minus 2. So that is the dimensions. This is the dimension. 1, 1, 2. So this is the power raised, or this is the exponent raised in the particular equation. So the dimension is the power raised in any equation, and this power is raised with respect to the physical, you can say, fundamental quantities. So this is the dimension. Now we will be switching over to the application of dimensions. The application of dimensions are vivid, and it is of very useful in nature. This finds application in deducing various type of relationships. The first and foremost, it is homogeneity. The first application and which comes under dimension is homogeneity. We will be taking some of the examples which can render more transparency, and our concept will be more clear. So we will be taking first example, that is homogeneity. Homogeneity. HOMOGENITY. Homogeneity. As the word suggests, as we had studied in the lower class, that homogeneity means, in other words, we can say equal, of similar pattern. So, whenever the homogeneity comes in the context of the dimension, it means the dimension in the in the left hand side will be equal to the dimension in the right hand side. So that is the homogeneity. The dimension in the left hand side will be equal to the dimension in the right hand side of each and every quantity. So we will see one example, then our concept will be more clear regarding this context. That is homogeneity. We will be taking one example regarding this. That is, we will be taking some of the more examples regarding this first and foremost. So first and foremost, we will be taking one more example, that is the famous equation x is equal to ut plus half at square. This is the basic equation of a motion. This is the equation of a motion in which the slope is, you can say the slope is u, and the intercept made on the y-axis is half at square. That is the equation of the motion. We will be first and foremost, we will see the notation or the nomenclature of various type of fundamental quantities. When we are talking according to the context of the dimension, that is mass. Mass, it is m. It is written under the bracket m. Length is l. Time is t. So this is a basic notation or the way of writing whenever we are writing the fundamental units in the context of the dimensions. So we will be taking LHS and we will taking RHS, and we will see how that the homogeneity prevails. So when we are taking the LHS term, x is L, we can write L in the right hand side. UT, U means initial velocity. And the velocity we had already seen, velocity is equal to length by time, LT minus 1. So it will be LT minus 1 into t to the power 1. Already t is there. Understood? Now plus half. AT square. AT. A is the acceleration. Acceleration is the change in velocity. That is velocity LT minus 1 by t. That is LT minus 2. LT minus 2 into t to the power 2. So we can write here L is equal to L plus L. So we are seeing here the equation, the final equation which we had got, in which the dimensions of each and every term is equal, no matter whether it is right hand side or left hand side, irrespective of the location. We are seeing here that the dimension of each and every quantity is equal, that is L. So we had already stated and we had proved here that this particular equation, it is following the homogeneity. The homogeneity is prevailing. So it is one of the application of dimension. Now we will be switching over to the next application, and it is also one of the most important, you can say, application, that is the conversion of units. Conversion of units. The conversion of unit, it is very important aspect under the context of the dimension. The conversion of unit, there are basically some standard type of units which are universally expected apart from MKS system, that is mass kilogram second. Mass, MKS system, it is mass and kg and second. FPS, foot pound second. So these are type of centimeter gram second we can use. MKS is it is abbreviated as meter kilogram second. and CGS is centimeter gram second. So we will be taking one example which will illustrate how we are converting one form of the unit into other form of unit, that is MKS to CGS. Suppose we are taking the example of pressure. Pressure is equal to force per unit area. SI unit of pressure is Pascal, as we had already studied in the lower classes, and that Pascal we are calculating, we are taking in the context of MKS, meter kilogram second. We will be converting that MKS into CGS using the concept of dimension. So first and foremost, pressure is equal to force per unit area. So we will be writing here, it is pressure, the force is equal to LT minus 2. Force is equal to LT minus 2 by area, that is L square by L square. We will be getting L minus 1 T minus 2. Understood? We will be getting L minus 1 and T minus 2. So we will be using this basic equation and we will see force is equal to mass into acceleration. So it is ML. It is ML. M L minus 1 T minus 2. That is the writing this in the context of the dimension. Now we will see the basic conversion, that is MKS by CGS. Mass, you can say 1 kg. Mass is the 1 kg here by 1 gram. Understood? Length is meter. M to the power, suppose it is minus 1, it is centimeter. And time is second, t to the power minus 2 by t to the power, and you can say t to the power, it is minus 2, 1 second only. So it is 1 meter and it is 1 second. It is 1 second to the power minus 2. So whenever we are doing the normal operations, 1 kilogram, it is equal to 10 to the power 3 gram. We will write here 10 to the power 3. Now coming to the meter section. 1 meter is equal to 100 centimeter. So we will be just writing here 10 to the power 10 to the power 2. It is 10 to the power 2 to the power minus 1 because it is whole to the power minus 1. Now second, whenever we are coming to the second section, in the second, irrespective of the international system of unit, in each and every aspect, the SI unit of time will be second. So it will be cancelled out. So here we are getting 10 to the power 3 into minus 2, 10 to the power plus 1. So 1 MKS, that is 1 Pascal pressure, is equal to 10 CGS pressure. So we had deduced the relationship between MKS pressure and CGS pressure. The MKS pressure is Pascal. So 1 Pascal is equal to 10 to the power 1 CGS pressure. So this is the another application of dimension in which we are seeing how to convert one system of unit to other system of unit. That is the conversion method. Now third, we will be saying the deducing the relationship between the quantities. The homogeneity is also finding an application in deducing the relationship between the physical quantities whenever we know the dependence of the, you can say, different quantities on someone, and this dependence will be in the product in the form of product form, that is multiplication form. We will see how we are deducing the relationship. Please focus on the board. So the third application is deducing. Deducing the relationship, it is an important aspect. Deducing relationship, deducing equations. We will be taking the example of time period. Time period is equal to T is equal to 2 pi under root L by G. That is the formula. We know that is the formula. T is the time period of the simple pendulum, and time period, if we are knowing the dependence of this time period of, you can say, T is directly proportional to the mass of the bob, length of the bob, and acceleration due to gravity, that is G. So in these three factors, the time period of the simple pendulum depends. As per our convenience, we are taking these three factors. Now we will be elaborating this in the context of dimension. T is equal to K into M into L into G. We will be writing in the dimension form T is equal to K into M to the power 1 into L to the power 1 and into g. G is the acceleration due to gravity. Acceleration is change in velocity by time. So it will be lt minus 2. It will be lt minus 2. And here t is raised to the power of 1 and other will be raised to the power of 0. So anything to the raised to the power 0 is 1 according to the rules of mathematics. L0, T1, M0. It will be k into m to the power 1 into L to the power 1 into L t minus 2. Understood? Now we will be equating the various type of equations. Suppose we are writing m raised to the power of a, L raised to the power b, g raised to the power c. So it will be a, b, c here. And now it will be m raised to the power a, L raised to the power b, and acceleration due to gravity is raised to the power of c. So we will be equating the various as the bases are equal. So we will be equating the exponent part. As in the indices part in the mathematics we had already studied, if the base is equal, we are equating the exponents. So using the same application here, using the same concept here, we will be equating the exponents. So L to the power 0, L to the power b, so b is equal to 0. Now m to the power a, m to the power 0, a is equal to 0. Now we had already seen here L, b plus c into t to the power minus 2c. So we had already seen here a is equal to 0 and now b plus c is equal to 0. Now b plus c is equal to 0 as per the equation. And t to the power minus 2c is equal to 1. So minus 2c is equal to 1, c is equal to minus 1 by 2, b is equal to 1 by 2. So we had got all the unknown indices, that is a, b and c. And we are seeing here that t is equal to k into m to the power 0, 1 into L to the power half into g to the power minus 1 by 2. Whenever we are writing in the equation form, it will be t is equal to k under root L by g. And that k is 2 pi under root L by g. So we had deduced the equation using the concept of dimension that t is equal to 2 pi under root L by g, where t is the time period of the simple pendulum, and this equation, it is independent of the mass. It is this time period depends on the length and the acceleration due to gravity. So we had deduced the equation, and this is the basic procedure of finding the relationship between the constant using the concept of dimension. And as far as dimension is concerned, each and every aspect in each and every entity in this universe have certain limitations. So dimensions is also having some of the limitation.